Okay, everybody. Good afternoon if you are not all the way on the West Coast, in which case, good late morning to you. Thank you very much for joining me today for a deep dive into UVC technology. Now, this is an encore presentation of this webinar. I did this webinar last week, and I learned from that webinar because this is a process or a technology that I'm very enthusiastic about, and I went into way too much detail last time. So what I will ask is, if I am starting to lose you, if I'm going into detail that's a little bit too much, please go in the chat box, please go into the Q&A box and tell me to hurry it along. Also, at any point, if you have questions, please use the Q&A module built right into Zoom to ask any questions you might have. I will take some time at the end to address questions and answer. So I hope that I find you well today, that you're healthy, that your loved ones are healthy, and that you're starting to prepare your way into the reintegration into the new normal after this time of coronavirus. This is a time that for all of us that are responsible for facilities or companies or institutions of some sort, we are trying to find ways that we can safely re-engage work, school, activities, whatever it might be. So thank you for taking some time to dive into UVC technology. This is something that has a lot of promise, has been used for quite a while, as we'll go into, and I hope it's something that you at least consider to implement. So let's get in right here. So my name is Dan Littman. I am the Director of Development at Pure UVC. My responsibilities there are marketing, educational initiatives just like this, and internal systems. So I've had a little bit of leeway and input on the engineering and design of the system, but for the most part, minds that are much smarter than I am were the ones putting that together. I do have a bachelor's of science in electrical engineering from Rutgers University. So those of you that are here in New Jersey, that is where I currently reside. That's where I went to school. So I guess go Garden State. So let's get into UVC technology a little bit. So UVC is here. This is technology that with the dawning of COVID-19 and the coronavirus has seen a huge uptick in attention. This is an old technology, as we'll get into, but there have been many applications, as you will see from the Pure UVC system in a little bit. So a few applications that we'll see now are, if you look at the top left, this is the MTA, this is the Metro Transit Authority, the subway system in New York City. And again, I'm from New Jersey. I go into New York all the time. When I say the city, it is New York City. And the subway is one of the grimiest, most disgusting places that there are. So UVC technology in order to disinfect against bacteria and viruses like the coronavirus. But like I said, bacteria in general, to keep it safe is a great thing. Top right image is a Whole Foods market. Amazon and Whole Foods, as a subsidiary of Amazon, are implementing UVC robots to disinfect between aisles, whether it's at a supermarket or if it's in one of their facilities, their fulfillment facilities. Bottom left is a prototype by Hyundai to bring in UVC technology into their cars. So when a passenger leaves the car, there is a sweep of UVC throughout the inside of the car for disinfection. And the bottom right is a Boeing prototype. This is actually something that they've been in development for beyond the time of coronavirus. This is about 2.5 years old. And the idea there is that between bathroom users in an airplane, a strong surge of UVC light disinfects the bathroom before the next guest comes in. Again, like the MTA, airplane bathrooms can be a little bit gnarly and grimy, so a nice application of that technology. And continuing on with this, since coronavirus has hit, there has been a lot in the news about applying UVC technology for disinfecting against coronavirus. There is proof that UVC is effective against coronavirus. There's going to be many more papers that come out as the, let's say, medical research and peer review process catches up. So a lot of interest, and it is something worth getting a little more information about so you understand what this interest is about, which is the idea of today's webinar. So let's do a little bit of a history lesson here. So we have in the early 19th century, UV light was first detected. Now in 1877, two scientists, Downs and Blunt, they accidentally discovered the antibacterial properties of sunlight. Now, UV light naturally emanates from the sun, and what these two scientists discovered was they were trying to replicate the work of another famous chemist, Louis Pasteur, as we know from the process of pasteurization. And they were literally trying to make a petri dish of bacteria, but they put it on the windowsill of a very sunny window, and they noticed that nothing was happening. Even though they were properly putting in all the food and everything that the bacteria should be able to thrive under, the bacteria was being killed by the sun. In 1901, the first UV lamp was commercialized. In 1904, Niels Fenton won the Nobel Prize in Medicine for using UV light to treat tuberculosis. 1910, the first major UV water disinfection system was utilized in Marseille, France. Even to this day, two of the major applications of UV light for disinfection are going to be water treatment and air circulation treatment. So you'll see the HVAC UV systems. That is not what we do at Pure UVC. We have a facility-wide solution, which we believe is going to be more of the time, but we can go dive into that a little bit later. 1934, the first modern fluorescent lamp was developed, and even to this day, if you're using fluorescent lamps, the technology is more or less the same. And why did I bring this up in a discussion on UVC light? The reason why is that the fluorescent lamps that you hopefully don't still have in your facilities, if you do, it is time to switch to LED. LED is inexpensive. LED is much more eco-friendly. It lasts a longer time. In every way, LED is better than fluorescent, but you most likely have experience with fluorescent lamps. They were the type of lamp for a very long time. Fluorescent lamps and UV lights are essentially the same exact thing. There's just two differences. One is the internal pressure. Two is that the fluorescent lamp has a coating. So if you look at a fluorescent lamp, it has a white coating. That white coating absorbs the UV light and converts it to visible light. So this is a technology that you've probably had in your homes, in your schools, in your offices without even realizing it for quite a while. Continuing on, William F. Wells demonstrates the efficacy of UV light to disinfect airborne pathogens in 1935. As mentioned, another major application of UV light. In the 40s and 50s, it was the opposite of UV's heyday. Two things happened. One, the rise of antibiotics. Penicillin was discovered in the early to mid-early 20th century and really took a huge step forward in terms of treatment in the 40s and 50s. And the other thing that happened was bad research happened. Some poor research without doing proper case studies occurred. There's a dip in popularity of UVC and UV technology. But in the 50s and after, more research has been done, more specific applications have been used, and this technology was used again, water treatment, air filtration, but used in hospitals, medical facilities, research labs, and food processing factories and plants quite predominantly. And now we get to 2020. COVID-19 has come. This has changed the landscape of the world, and with it, ways to disinfect against disease, ways to prevent the spread of future pandemics has taken center stage. And with it, there has been a resurgence of UV and UVC technology. Now, what is UV light in the first place? UV light is part of the electromagnetic spectrum. It falls just underneath the wavelength, so just a shorter wavelength of visible light. In fact, UV light is just a little bit more energetic, just a bit of a shorter wavelength than violet light, and therefore it's called ultraviolet light. I don't know if that's a cheeky or a really bad name that the scientists came up with, but it's what we got. And UV light is something that we deal with all the time. It comes naturally from the sun. Some of it filters through the atmosphere, some of it doesn't. And we see it when we go to, I don't know if any of you guys during your college time went to those crazy, blacklight parties. That was UV light at play right there. So while all the cool kids were dancing and doing all the proper things, the engineers like myself were gawking at the lights and trying to figure out how that stuff worked. But let's not make this about me. Let's continue back to the technology here. So with UV light, there's 4 segments. You've probably heard me say UVC a bunch of times, and you might be wondering, what do I mean by UVC in comparison to UV? So there's 4 bandwidths of UV light. There's UVA. This is the thing that we deal with most often when we talk about UV light. It comes from the sun. It filters through the atmosphere, and it is responsible for giving us a beautiful suntan. It's something that over a long period of time is carcinogenic, but that's a long period of time. For the most part, it's pretty benign. It does have some disinfecting properties, but not really that strong. It can disinfect against bacteria, but isn't so effective against viruses or mold spores. And this is what we use in tanning beds and black lights. About 95% of the UV light that is on Earth is UVA. Then we have UVB. This falls down to 280 to 315 nanometer, the wavelength section. This is about 5% of the UV light that filters through the atmosphere, and this is what's responsible for burning our skin. This is what's responsible for when we look at the sun and we get the eye spots. That's called photokeratitis. And over a long period of time, it can cause skin cancer and it can cause cataracts. This is the reason why we wear sunscreen. Now, UVC, this is the main thing that we're talking about. UVC is a shorter, therefore more powerful wavelength. And this is incredible for disinfection purposes. This is the #1 use of UVC on the planet. UVC does not filter through the atmosphere, and so it does not occur naturally on Earth. It has to be created through special fixtures and special means. And there is, we'll talk in a few moments, a special wavelength range in UVC, which is especially effective. And then we have one more based on where you're looking and who you're talking to, and let's say what background they have. It might be called VUV, I'm sorry, we have a typo there, or EUV. And this only occurs in a vacuum. Therefore, it's not on Earth. I believe that there's some application of it in computing and in semiconductors, but for the most part, this isn't going to be used for disinfecting or for many commercial applications. So we'll more or less pass that over. So why use UVC light for disinfection, and more or less how does it work? So UVC light it has a high enough energy and it has a small enough wavelength, meaning that it could go penetrate into the actual cells, into the DNA and RNA of the pathogens, our viruses, our bacteria, our mold spores. It's amazing. UVC is amazing in that it treats all 3. Even chemical disinfectants might not get to that point, and other types of light, let's say light disinfecting, won't be able to get all 3. Continuing on though, UVC gets into the DNA and the RNA of the cell itself, the pathogen. What it does is that when it's time for DNA to replicate, it pretty much unzips. We've all seen that helix structure of it. So imagine taking both ends and unzipping them. They unzip, another end comes, and from 1, now we have 2. What UVC light does is that it pretty much glues it together so it can't replicate. The way that diseases infect the body is through replication in the body. So by being unable to replicate means that it can no longer infect. So UVC light will go and render pathogens inert. This peak of this happens between 250 and 270 nanometers. So all the technology that we'll be using is in the 254 nanometer range. And at this range, it can provide 99.99% disinfection. So long as the UVC light is exposed to the pathogen, it's going to be essentially complete and utter disinfection. And so long as UVC light is applied for the proper duration of time, those pathogens will not be able to heal themselves like they might be able to do under certain other means of disinfection. And then finally here, you'll see if you research that there are other wavelengths of light that do have disinfecting properties. So for example, there's what's called GUV, which is germicidal UV light. So this can happen at higher ranges on the spectrum, around 380, 400, maybe even 420 nanometers. The nice thing about this is that it can be on all the time. We'll talk about some of the falling off points of UVC in a little bit, but it takes a very, very long time to disinfect, number one. Two is that it might not provide total disinfection, meaning that either what was disinfected can heal itself, or it's not going to get that 99.99%, not even 99%. And three, it can only apply to bacteria. It's not going to be able to apply to viruses or mold spores. And then there's another side 185 you might hear of. One of the byproducts here is ozone, and ozone is in its own right a wonderful disinfecting property. It's something that if you're looking to, let's say, obliterate a room, might be a good option. There is a couple falling off points here. One is that ozone is going to prevent the passing of UV light. UV light is easily absorbed. It's going to be absorbed by the ozone. So essentially, if there's ozone produced from a UV fixture, the UV side of things is not working anymore. And two, to disinfect with ozone, to have enough ozone, needs at least 1 hour, maybe more, when the system is off, with good air circulation to filter through, because at that quantity and at that density, ozone is incredibly dangerous for the respiratory system. UVC at the 254 nanometer range has no residue, no odor, so the light turns off, you can walk straight in, no issue there. All right, so again, this is the deep dive into UVC. So if at this point you're thinking, oh man, what did I get myself into? There's this guy just geeking out right now, and I'm here just sitting around listening to this. We do have Thursdays, we will for the summer do every other Thursday, our intro to UVC webinar. So feel free to sign up for that. But I hope that I can continue to make this interesting for you. And I hope that this is a time that you can take a sip of water, catch up a little bit before we go into the next deep dive in. So what are the factors we need for UVC to work properly? And we're talking now about much of the UVC that you're going to be seeing for your facilities. So this is going to be those Amazon robots. This is going to be our permanent solution that we're talking about, Pure UVC. This is your portable solutions, whatever it might be. One, energy intensity. The stronger the light, the more disinfection it's going to be doing. So think about your normal LED or fluorescent lights. If you have a low wattage light, it's not going to be able to light up a whole room. If you have a high wattage light, it's going to be able to light up the whole room, and you're going to have brightness you can be able to see. Same idea here. You need high energy in order to disinfect. So a low-powered UVC light can go and do a little bit of disinfection, but it's not going to get that 99.99%. Now, on the other side, getting too much energy, there's going to be a falling off point there in that, one, it's going to require at this point a lot of electricity. So it's going to be some large cost to go and create dedicated circuits there. And two is that the actual fixture itself, the actual bulb, the heat that's created there, and the pressure that's created in there, it might not be able to take it. And in that case, it will shatter, which is going to cause its own level of danger. So there needs to be it needs to find a happy medium with what energy intensity it can have. Now, based on the energy intensity, we need to talk about exposure time. The longer that pathogens are exposed to UV light, the more it's going to be disinfected. The solution that we have takes about, let's say, 2 hours to have a comprehensive disinfection for most typical applications. But if you have a weaker light, or if you have a larger room, it might take more time. Distance from source, same thing. Think about your LED light that's in your room, right, or in your home. right underneath, it's bright, but when you get to the corners of the room, you get those little dark spots. Same thing. There is an exponential decrease of intensity the further away from the light that you get. And so there needs to be enough light, enough sources of light throughout the room in order to keep enough energy for the disinfection to occur. This also means that shadows need to be covered as best as possible because UV light can only treat what it can see. Now it could treat airborne and surface pathogens, which is a plus, but again, it needs to be in the line of fire there. Next up, airflow. So we have a permanent install fixture, whether it's in the ceiling or it's a portable unit on the ground. It's shining out, and let's say it has this beam of light right here. It's shining out. Now we have on both sides, we have pathogens, airborne pathogens. Now, if the room is completely inert, then all that's being treated is here. Having good airflow is going to ensure that all this gets passed through this strong beam and can be treated well. So if there's good airflow in the room, the rate and quantity disinfected, especially in the airborne side, is going to be much better than if there's weak airflow. We do build in fans into our fixtures themselves for that, and do encourage having some sort of AC, whether it's central air or forced air, whatever it is, to provide a little bit more of that movement through. And finally, temperature is important. For the most part, things are going to be at room temperature with little fluctuations there, but the lower the temperature, the more energy is required for disinfection. It's one of the reasons why a lot of scientists are believing that through the summer, the spread of coronavirus is going to take a little bit of a dip, and it's going to rise back up come autumn when the temperatures dip again. All right, and then let's get into some benefits here. I already talked about a lot of them, so I'll try to fly through this. Efficacy, 99.99% airborne and surface level pathogens. Safety, so long as the system is controlled. So long as no one is under the light, we'll talk about that in a brief moment. It is an incredible safe system because there's no hazardous residue. Chemical disinfecting products, they do have a harsh chemical residue. This residue can cause things like headaches, all the way down to migraines or respiratory issues. There has been research that shows that people that work with chemical disinfectants on a daily basis, think about your facility teams, their risk of lung cancer is significantly higher. So this is going to be a safer system on that side, again, so long as it's properly engineered. Workplace friendly. It allows for comprehensive daily disinfection, airborne and surface level. This is going to be nearly impossible through manual alternatives, through just taking your cleaning products. You're gonna have to have a small army of a team to do that, and it's going to cost a small fortune. This also allows for scheduling of the system. So based on your facility's needs, it allows there to be disinfection. So let's say you have a meeting room and there's a meeting from 12 to 1, nothing from 1 to 2, and a meeting from 2 to 3. UVC can kick on from that 1 to 2 period, that middle period, disinfect, and allow that next meeting to come through in a safe way. Next up, future proof, or let's say future ready to keep things simple there. The lawyer on our team here has kicked my butt a few times for calling it future proof because she said that I'm not Nostradamus and I can't predict the future. So that is true, but for all pathogens, all bacteria, viruses, and mold spores that have been tested, to my knowledge, all have been susceptible to UVC light. This will most likely continue because it's not the antibiotic resistant properties of the pathogen. It's the nature of a pathogen itself, which is susceptible to UVC light. So yes, it works against coronavirus, but it's also going to work against your common flus. It's going to work against your colds. It's going to work against antibiotic resistant superbugs, because again, it's not about what happens in the body. It's just the nature of it outside of the body. And it should work against our future epidemics and pandemics. So a good, smart investment. Less waste, it's a greener solution. You won't be going through as many containers of cleaning product, and that cleaning product does need to be disposed of in the proper way. And lamps are going to last at least 5 years, anywhere between 5 and 12 years, depending on how they're used. And by the time you're replacing your next lamps, most likely LED technology will come in, meaning that you likely won't be replacing another UV lamp after that next generation for the rest of your days in your facility. And then finally, affordable. A standard 800 square foot classroom costs around $2,100. This is, when we compare this against the materials and labor to do a equivalent cleaning on a daily basis, it is a completely affordable and just intelligent budget solution to make there. All right, so let's continue on and go on the other side. So I talked about how great UVC light is. I am completely biased, I won't lie, so I need to go and talk about some of the potential dangers of UVC light. Number one, ozone. So as mentioned before, wavelengths in the 185 nanometer range, they do disinfect, they do work, but they produce ozone. Ozone is, in of itself, when it's in small doses, it's not a big deal. You smell ozone before a thunderstorm strikes, but at the quantities that is needed for ozone disinfection, it causes a lot of damage to the respiratory system. This is going to especially be more dangerous for people with pre-existing respiratory conditions and younger kids. Ozone is highly reactive, and I mean this in a good way. So ozone is O3, so 3 molecules of oxygen. The oxygen we breathe is O2, so 2 O3s will meet each other and they'll create 3 O2s. That process does take time, so you'll need to keep the place vacated for at least an hour. And it also does require some good airflow so those different molecules can meet each other. Next, the major thing that we need to be concerned about with UVC light is skin and eye damage. Just as if you sat under the sun on a hot summer's clear day, you would get a sunburn. Same idea can happen with UVC light if there's extended exposure. It is for that reason, it is of the utmost importance you have a system that no one is going to be under. And if for whatever reason you need to be under the light, that you are wearing the proper safety precautions, long clothing to protect the light from touching. And if you're looking at the light, then safety goggles. Safety goggles are very affordable. I think they're literally a few dollars on Amazon. And for our facility-wide solutions, we do provide a little goodie bag that does include some goggles, some very stylish goggles, I should add. One of our salespeople was just telling me that the other day about how cool the goggles look. So on that side, that's the number one thing to be concerned about. It's one of the reasons why you need to go and vet any company you work with to make sure that they are providing good quality equipment and that they have thought about risk mitigation. And the last thing to mention is discoloration. So if you have ever had, let's say, an old computer monitor right by the window, you might have noticed that over time, the white turns into a bit of a yellowish brownish color. Same idea happens here because we're harnessing the energy of the sun here. So it's going to occur more or less at the same level of time as sunlight would discolor something. This is going to apply to certain plastics. It's going to apply to certain types of furniture, and it's going to apply to certain paints. And by paints, I mean like the paints that you would use to paint a picture. To work with this, there's a few things that can be done. One, some of those things that need to be covered, like a student's watercolor, for example, you could go put that into a closet during disinfection times. Two is to go and engineer the system so the walls where the paintings aren't going to be touched. And three is for especially things like paintings, you could get just a frame which is going to inhibit the light to come through. So for example, the Declaration of Independence at the Smithsonian in Washington, DC, does have a special glass enclosure which prevents the natural UV light from the sun to come through to prevent the Declaration of Independence, this incredible document, incredibly important document to the US, to prevent it from wasting away. And so we could have it for many, many more generations to come. Same idea, UVC light doesn't penetrate through a lot of mediums well, so it's not going to be a very expensive or fancy type of frame you need to buy. All right, and now let me get into our system here. So I know I'm already a bit over time with this webinar. I get carried away all the time, so thank you for sticking along. I'm going to go try to fly through our system. If you want to learn more about it, join me tomorrow. I have another webinar where I'm going to dive into this more. It happens normally on Thursdays, and we'll be doing some more different facility-specific webinars in the future. In a few weeks, we'll launch a school-specific webinar so you can see how this app will apply in different facilities. So generally, we're going to talk about a classroom solution here just to get the conversation started. We've all been in classrooms before, so we all know what a classroom is like. With the system, during the day, nothing changes. There's a couple UVC-specific lights in the room that turn on only when the room is unoccupied. Mostly that's going to be overnight, so let's say midnight to 3 a.m., but it can also be programmed so it's working between off periods. So let's say period 4 is off, you could schedule it so it works during that time. So this is a rendering of what something might look like when it's activated. So something that we make sure that we do is multi-point lighting. So there are multiple fixtures in the room. It's one of the reasons why we need more than just one light source. We need at least 2, but 3 or 4 is preferred if possible, but 2 is going to be adequate for most normal, let's say, classroom sizes. And what this allows is it allows for shadows to be covered. So when one light is making a shadow, the other one hits that shadow, and you're able to maximize where the light is touching. So as a company, things that we go and provide our clients are room-by-room treatment plans. So we talked about before, based on the ceiling height, based on the layout of the room, based on where the edges of the light are going to be, we'll give you the time, how many hours the light needs to be on to provide that 99.99% disinfection against viruses, bacteria, and mold spores. We'll provide fixtures based on the aesthetic of the room and based on what's there. Again, drop ceiling versus fixed ceilings. We'll go and do, like I said, proper duration disinfection. We'll pre-program controls, and we will provide educational materials so authorized users can make their own schedules with the controls. We'll talk about that in a moment. Room-by-room layouts. The fixtures are very simple to go and put in, so the contracting team that you like to use, and for some of you that do have a bit more of a robust facilities team, they'll be able to do it themselves. Again, simple enough install. We do rigorous testing of all tech and systems and provide tech support, a no questions asked warranty process, and a high-end customer service. And so again, overview of the system. It's on only when the space is unoccupied. Typical classroom with 2 fixtures will require 1 to 3 hours for comprehensive disinfection. And we have a few safety protocols. So we have local occupancy sensors, high-end occupancy sensors. So if someone is walking towards the range of the light will click off and will only click back on about 5 minutes after the room has been deemed empty. It does not interfere with any existing lighting systems. We have our IntelliSafe app-based controls. We'll talk about that. And as I mentioned before, we have built-in frictionless fans to raise the efficacy of the system, to increase the airflow so there can be better airborne disinfection going on. So the IntelliSafe controls are something that we've taken a while to engineer. This is something that we use not just in our UVC systems, but in our LED systems as well. And this is something that a lot of clients have been very excited about and have been using in very specific ways. So it's an app-based control system. It allows flexibility of use and allows for customized presets. We do send you the app with preset programs based on your needs and based on common needs, but you'll have the opportunity to set it directly to your facility's needs. And it's a very intuitive, very simple app to use. You do receive a video going through a tutorial so you can go and learn how to program your own schedules. And the safety features that are part of the control system is astronomic clock built into every fixture. This is saved through the fixture itself. It's saved through the phone app. So if there's a power outage, nothing changes. The fixtures are still working at the time dedicated and determined previously. Smart sensors, occupancy controls. So if someone enters the space, the fixtures are going to turn off. There's manual override through the app and through strategically placed switches. So if, again, safety redundancy, we over-engineer the solution just in case. We don't want to act smarter than we are, so we want to go and provide multiple levels of safety there. So if you need to turn it off for whatever reason, very simple to do that. And the little cheeky thing that we do is that fixtures will deactivate as default. So if anything goes wrong, if the sensor is registering that's not working, if the fixture has lost, let's say, any access from the app, whatever it might be, the fixtures turn off, they won't turn on, we'll be notified, and we'll go and provide you some sort of remedy, whether it's some tech support or it's a new unit. So again, a lot of work goes into this. We just mentioned that and you listened through for 30 minutes, so I'll pass this on. In terms of costs, this might be something that you're curious or concerned about. So an average room, as we mentioned, for a classroom, about 800 to 1,000 square feet. Materials will cost about 2,100. So it's very affordable. You won't have to change bulbs for at least 5 years, and bulb replacements at this point are about $40 per bulb. So really not too expensive at all. A small building, let's say an elementary school, will cost about $55,000. Medium, middle school will be $125,000, and a large school is $190,000. This is materials. And again, this is going to last you for at least 5 years before bulbs need to come in, which are just going to be a small cost. And this is also going to provide daily disinfection against not just the coronavirus, COVID-19, but against flus, colds, and future epidemics as well. So last thing I'll say before I enter Q&A is let's talk about the future of UV disinfection. Again, deep dive. So let's go see where we're heading. So we're heading towards the LED UVC revolution. We already had that where fluorescent normal lighting was replaced by LED. The same is going to happen in UVC, but at this point, LED UVC is not powerful enough and it's price prohibitive. So it's not at the point that we can implement it facility-wide. But when we do, we'll have more control over what wavelengths of light we want to emanate. We'll have more control over how long these fixtures last. And we'll also be able to implement things like dual purpose technology, where we have half the LED is normal light and then the other half is UV light. And so you can have one fixture that does everything you need. There'll be continued regulation. So with more adoption of facility-wide UVC technology, there's going to be more governmental agencies involved. I was actually just on the phone with a representative from the state of New Jersey talking about UVC technology. The EPA does monitor UVC use, so make sure that the products that you're using are certified by the proper agencies in order to make sure, again, that they're safe and to make sure that you're meeting all governmental restrictions here. As companies too, we take on some of the risk there. So make sure you're working with someone that's reputable or someone that's going to work with you to make sure that the best solution is provided for you. And then finally, 222 nanometer far UVC. So there's been tests at Columbia University of a different wavelength, 222 nanometer, that does have very good disinfecting properties. And from initial tests, it does not cause any damage to the skin and to the eyes. A lot more research needs to come through. It hasn't been tested on humans, it's been tested on other mammals. And we need to go and make sure that anyone with a pre-existing condition, we need to make sure that people with sensitive skin, that this is going to be what it says it is. But if it is, it's a solution that you'll be able to leave on during the day, and we'll be able to provide a comprehensive disinfection perpetually through the day, which will solve a bunch more needs. The nice part with working with Pure UVC is that we always stay up to date with technologies. So if you get a current model UVC system, first, all the controls will be automatically updated whenever there's an app update. And two, if 222 becomes something viable, then it'll be as simple as taking out one bulb and putting in a new bulb, and you'll be able to get the latest and the greatest of technology. So we have some more webinars coming up. So tomorrow I'll be doing an intro to UVC lighting, 1 p.m. Eastern Standard Time. We have a bunch of recordings, and towards the end of the week, we'll be announcing our new wave, let's say our summer schedule of webinars. So hopefully you'll join me in the future for more of these educational opportunities. This is being recorded right now. It will be published to our website by the end of the week. So if you missed something, or if you want to share it with someone, you'll be able to do so. So that said, thank you very much for sticking on for a deep dive into UVC technology.